Hello again, welcome back. It's time for another full restoration video series, and this one is no different to a lot of my radios. It's a German set. This one's from 1960-61. It is a Grundig, and this one is a 4198 stereo. Now when they say stereo, they mean that if you use the pickup input, it really is stereo, but if you use radio, including FM, it'll be a mono signal. That's quite usual because FM stereo only came in really into the market a little later than that. I have no idea what condition it's in electrically. Physically, it looks pretty good. It doesn't have too much damage. The grill cloth is in pretty perfect condition, just needs a good cleanup. And the woodwork, it's already in the modern sort of lighter wood, more squarish look that took over in the 60s, early 60s. This one is a lot more modern. It doesn't have too much damage on the wood itself. It will need sanding all the way down to the wood, and I'll probably then leave it in a light color, as I've done before with one or two of them, because I like the contrast between these and the classic dark ones. Other than a couple of little chips here and there, it seems to be in perfect condition. As you can see, there is a slightly bigger chip down there, but we can repair that. That's not a problem. As for the radio itself, besides that side speaker grill over there, we have the central speakers on the front here, which you can see, and at least one really big one. And then we have another grill on the other side. So I expect to see at least 3 speakers, which would make sense because this being stereo, you'd need to have at least 2. And these guys like to spread the sound, so 3 is probably what we're going to see in there. The condition of the faceplate is perfect. There is a chip on one of the knobs over there. We can probably repair that. A bit of tarnishing and so on. Dirt, nothing unusual. But I'm glad to see there's no chips on the faceplate or anything like that. The piano keys seem to be intact, albeit quite filthy. Now function-wise, what we have here is, starting from the left, we've got the off, the aus button, TA is pickup, LW long wave. We'll skip those for a second, and we have the other channels here, medium wave, KW is short wave, UKW is FM. Then in the middle here, we've got these pre-selectors, one for stereo on the left there. That's obviously to activate stereo. Then you've got jazz, which is a preset tonal control. That Wunsch something whatever, I have no idea what that means, but it's obviously a tonal thing as well. I'll have to look that up. And then we've got orchestra, which is another tonal preset. But we also have these neat, this is like a 4-band graphic equalizer, which we've seen before in the 3060 that I did. And they work very well on that one, so I'm looking forward to seeing how it works on here. The FA and AS button is ferrite antenna or external antenna, so that's a pre-selector as well. Now you notice here on that, with the graphic equalizer, you've actually got the frequencies that those buttons will affect, and there's a little indicator which is broken in there. You'll see it when it's lit up. It's like an elastic that shows you the shape of the tonal selection that you've got in. So it works very well. I like that. The other thing I noticed here, which is unusual, is if you look at FM, it starts on 87 and it goes all the way across to 104 megahertz, which is 4 megahertz higher than the usual sets from the pre-60s. Usually they only went up to 100. Then we've got shortwave goes from 6 meg, 5.5 meg to about 16.5 meg. Medium wave is the usual, starts here from 510 to 1600 or so. And long wave, well, 450 to about 300 and, what is it on this dial? 350. So nothing unusual about that. But yeah, this looks like a pretty neat radio. It looks more modern, as I said. And I'm looking forward to getting into there and seeing what the sound is going to be like. Now with that size speaker, I expect it to be quite good, but we'll see. Let's have a look at the back. Here we go, nothing too untoward. and in pretty good condition. And as we can see, the speaker complement is more or less what I thought of. Big main speaker. There's a smaller one on the right, smaller one on the left, and there's also an electrostatic tweeter up there. So this thing should produce some pretty good sound. As for the condition of the chassis, we don't see much gone off here. There's a lot of dust, but there's no rust on here. No real obvious damage, and this thing should clean up very well. You can also see that the sockets they've used here are the more modern DIN connectors. When I say more modern, I mean for the late 50s, 60s. There's our FM tuning wheel on the left there. The flywheel is on there. There seems to be a dial caught loose in the back there, so something must have broken. The AM is over here. There's the AM tuning capacitor. One thing I've noticed is that the ferrite antenna is gone, completely gone, and strange. Anyway, we'll sort that out, not a problem. I also noticed that the FM section is underneath and not on top like some of the other radios, so this one's under the main chassis. There's our ECC85 FM tube. That one at the back there is the mixer tube, the ECH81. Then we'll have, let's look at the back of the cabinet here. There's a EBF89 over there and an EF89 here, EF80 here. That'll obviously be IF amplifier and probably first preamp, audio preamp, I'm not sure. But, oh no, there is an ECC83 at the back there, so equivalent to a 12AX7. That'll probably be, that's a dual triode, probably preamp. And then it uses one power tube that's a dual pentode. This is an ELL80, and I know they're a bitch to find, they're expensive. But what they do is they do the job of two output power tubes. So instead of using, say, two EL84s, they use one ELL80. Braun also used them. I found that in the in my Braun Atelier 3 that I've stored, and those are working perfectly. I'm not sure what this one's going to be like, but anyway, we'll sort that out when we get to it. There's our power transformer. Now here's a bit of a mystery. There's three transformers here. Now obviously I'd expect two output transformers. This being stereo, left and right channel, we've got three. So I'm not sure what's going on here. Maybe it's one output transformer from the main speaker and one each, maybe even in series for the two side speakers. We'll see. It's a bit unusual. But what I want to do here is I want to do something different. I want to actually, I'm not sure that I'm going to do that, but I'm thinking perhaps I should go into this with a little bit more detail, because I remember when I was looking at the first lot of videos, restoration videos that I was looking at when I was first getting into this hobby, I really got a bit annoyed when the presenter was sort of assuming that I knew a lot of stuff. Now, not his fault, but I really liked some of the detail, and I learned an incredible amount from some of the detail when they went into detail. So I may do this with this radio because I've got the schematics and it shouldn't be too complicated. I hope those aren't famous last words. I don't even know if the transformers are operational yet. I have no idea if this thing's working or not. None whatsoever. But I may, and I'm tempted to do that, go into more detail, looking at the circuit stage by stage, perhaps speaking myself through how it works, and perhaps, well, imparting some information to anybody watching this, because when you first going into this, you need as much information as you can get. And I remember feeling incredibly frustrated when someone would mention something and I had to go look up another 3 or 4 videos to try to find out what the hell he was talking about. And again, as I said, that happens to me already when I'm doing these. I just go through some parts which I assume everybody knows about. As I said before, this is these videos are more a restoration log for myself. I'm actually quite surprised that over 600 people have subscribed, and I'm pleased. I'm really pleased, but I really didn't expect this to interest that many people, and I'm thankful for it. So if you're watching this and you haven't subscribed, please do. I appreciate it. Right, so the next stage is to get this thing out of the cabinet, get it on that harness thing. I've built this these two aluminium brackets that I screw the chassis onto, and it allows me to flip it around and work on it without messing up any of the components at the top. It certainly makes it easier. You'll see it when I put it up. I'll have to desolder or disconnect any wires that are going to the speakers so that I can take the chassis out without the speakers, and then we'll be ready to have a look at this in more detail. To get this chassis out of the cabinet, I'm going to have to separate the wires that go off to the speakers. The way the speakers are wired, this is the one on the left, it goes to that binding block thing there in the middle. Same applies to that yellow and black that goes to the one on the right. And also in this middle one is the electrostatic tweeter over there. Now these wires wrap up and they come to the top of this transformer here. So what I need to do is to make a note of exactly where these wires connect, and then I'll just desolder, or rather just clip it there. And the reason I clip it is because I'll be soldering it fresh later on, so it ends up with a clean connection. Also, I don't want to be in there with a soldering iron at the moment because it's difficult to work on. The other thing is the big speaker then has these two wires coming down here as well. So what I'm going to do is make a little sketch, take some, well, this video will help as well, and clip them off, and I think we'll be ready to take it out of the cabinet then. They're clipped, just moved out of the way, and this little drawing with the numbering and lettering gives us the exact locations that they connect to. Now this is important because besides the speaker signals on there, you've got some that are high voltage for the electrostatic tweeter. So I'm confident now that I've got a good record of this, and I can go ahead and I need now to unscrew the screws at the bottom that connect the cabinet to the chassis. And here are the 4 screws. 1, 2, 3, 4. So here it is. The chassis is out of the cabinet, and what we're left with is obviously the whole speaker assembly over here and the antenna at the top, and then we've got, as expected, nice amounts of dust. So I put that aside now, and we'll come back to that later when we've done the electrical restoration. We can now get a closer look, and as expected, hell of a lot of dust, grime, but again, I don't see anything major in terms of damage, which is a good thing. Now to get this thing more flexible, movable, as you can see, picking this up is a bit of a problem. So I've got these frames, and all it is, it's a square, almost square aluminium frame. One strip of aluminium that was bent and then connected in the one corner. And these guys have got various holes on here. As you can see, this has been adjusted or added onto for various spacings that I've needed. And what I do is I'm going to find the 2 holes that match the position where the cabinet or the chassis was screwed onto the cabinet, and see if you can't find 2 matching ones. Yeah, I think we do. And we'll put that on there and screw it in from the bottom with the same screws that came out. I think that's about it. we go, we've got one side done. Now I do the other. So now that I've got this in the frame, see how easy it is to pick it up, flip it over, flip it right over, work on the side, work on the back, work on the top. It really is fantastic. Now you see I've got access to all the components on the top, or rather on the underside, without squishing any tubes or IF coils or transformers or wires. Everything at the bottom is protected, and this thing is it's sturdy enough. I mean, I've done about 15 to 20 radios with this thing, and I've never had a mishap. So this was really well worth the effort. And so now we're ready to move on to the next step. And the next step for me will be to get the schematics, see if I can find any other service data. I found the schematics, but I haven't found alignment instructions or anything. So I'll see what I can get, and then I'm ready to start. Now, as you can see, we've got a lot of work to do here because there are a hell of a lot of paper caps, those brown things. They usually leak like crazy, so they'll probably all have to go, and there are quite a lot of them. This is a stereo receiver, or rather amplifier in here, so it's got a lot of coupling, decoupling, and unfortunately they're all, or practically all, paper caps. There are a couple of electrolytics down there. There are a few, there's a little glassy there, that's polystyrene. Those are normally quite good. They don't go off value, they don't leak. The experience with the resistors on these Grundigs has been mixed. I've had some where the resistors have held their value very, very well, and I've also had one or two cases where they've been atrocious, and I've had to replace quite a few. So we'll just have to take it one step at a time and see where we go. And as I said, where we go is get the documentation, the more the merrier, and get ready to start doing some testing and checking before this thing even gets close to being powered up. I've managed to take this restoration progress one step further, in that I have tested the power transformer and the output transformers using the method that I've described in videos before, and I'll link to those above. And the good news is that everything is fine. The transformers are fine so far. Power transformers okay. The 3 output transformers test fine as well. So this takes us now to the next step, which is to carry on and do the check on the power supply section first. Now the first thing I'm going to do, this thing comes with this plug. It's got earth, European plug, but obviously, as you can see, there's no earth wire. It's a 2-wire cord. So this comes along and it flips in here with a protective sleeve, and it goes off to this connector here where the fuses are. I'm going to replace it with a modern cord. This one will have mains earth as well, and as you can see, it's got 3 wires. So what I'm going to do is I'm going to connect these 2, which is neutral, and the mains where those 2 are going, and then I'm going to connect the earth wire to a convenient part of the chassis. Now that'll give us a bit more protection, make it safer to work on. I don't want to end up with any shorts or mishaps along the way. So there we have it. We've got the ground wire properly connected to the chassis over here. I sanded a little bit of the chassis around there and on the back as well to make sure I got a good connection there. And then the live and neutral come up here and solder to the two lugs where they were previously connected. Now the one thing to bear in mind is you don't just touch it and solder it. You pull it through, you bend it over, you get a good mechanical connection first, and then you solder it. The whole point of, or the whole secret of point-to-point wiring is that you get a mechanical connection first, and then you just secure it with solder. You do not use solder to hold something in place. At least that's what it should be. Because if one of these wires got loose in here, you'd have mains and you'd end up with fireworks. You got the ground, or rather the mains, earth connected, which would trip a breaker somewhere, but you don't want to start that anyway. Right, next stage is get out the schematic and start tracing this power coming in all the way through into transformer, check for fuses, check everything along the way, check the switching, and see if we can't get some progress made on the schematic itself. Having a good schematic on these radios is essential, and I've found a few sites where you can almost invariably get the schematic you need for these German sets. And I say German, same applies to Dutch, the Philips, and so on and so forth. And the first one I normally go to is this site called nvhr.nl. It's a Dutch Nederlandse Vereniging voor de Historie. So the Dutch organization for the history of radio. And if you go here and you type in, you select schemas, then all you need to do is on here type in the make, Grundig, and the model number, which is 4198, and zoeken, which is search, and this is what you find. There is Grundig TE 4198 1960 receiver, and it says schema, and there you have it. This one is divided in 2 pages, so it's one schematic. It's only got the schematic. It doesn't have any other instructions. It seems to be pretty good resolution, and as you'll see in a minute, this is actually the one I've used, and in Photoshop I've joined them together so I get one schematic. The other one that I normally use is something called doctsf.com, which is French. And again, if you choose schemas and docs and you select schemas, then you select schemas by model, and you've got all the brands, the makes. So you go down here to G for Grundig. Where are we? Here we go. And if we look for 4198, stereo, there we go. It has one document, so you choose there, and you've got exactly the same thing as the other one, 2 pages, all right? The next choice is something called elektrotania.com. I think this is a Russian site. I'm not going to search here because usually when I'm looking for something on Elektrotania, I just put in this case, I'd put in Grundig 4198 service manual, Elektrotania, and it automatically finds it on here. It finds a lot of stuff on here, not just radios, but just about anything you can imagine, okay? And then, of course, there's the basic depository for all this information, which is radiomuseum.org, which I'm embarrassed to say I haven't joined yet, because when I was going to join, I needed to fill in some forms, and I really don't like to fill in forms, but that's my problem, not theirs. They do have a host of information. You can get service manuals and everything else here. If I remember correctly, there's a small fee, but it's very, very small. And I really have to join this sometime because it's really worth it, okay? So that's basically where I get the schematics. And if I don't find it in any of these sites, then what I normally do is I need to trolled through some of the restoration forums, some of them in German, by putting in, you know, the name, the model number, schema or Schaufplan as they call it in German. Sometimes it's easier because you'll have a lot of German forums with this with these radios, and then you just try and find somewhere where someone asks for a schematic, and sometimes you can get that there as well. I've had very, very few occasions where I haven't found the right schematic. One of them was actually a Grundig. It was 1099WE because it was a specific export model which they didn't have the schematics for. But we got through that because they're very similar to the other models. So that's where I get my schematics. And the result then, when I've taken those 2 pages and I've stuck them together in Photoshop, they didn't fit exactly, so I made a visible break along the 2 pages so I know exactly where they fit. The result is this. And I know this is daunting, especially if you're just starting off. But if you take this logically and you take it one step at a time, it actually makes a hell of a lot of sense. And you actually learn a hell of a lot as well. And it becomes a lot easier to handle, which is what I do. And the first thing I do is I tackle the power supply, because before switching this on, I want to know that it's safe. And to know that it's safe, I need to check that there are no shorts. I need to check the fuses in place. I need to check that the filter capacitors aren't shorted. I need to check that there's no blown resistors, and so on and so forth. And so what I do is literally, you know, start at the beginning. There's our beginning. There's our mains coming in. I know this is German, but hey, you know, a schematic is a schematic. You can practically guess what things are saying if you can't understand it. There's also Google Translate to help out, which helps a lot, believe it or not. And so here you have it. You have the mains coming in. It goes through a switch. This switch is obviously activated by the piano keys, the piano buttons at the front, and when you select any of the bands or the pickup input, and it switches off when you push the AUS button. So you look for that switch, check for its continuity, check for its function. Now this is always off, away from mains, nothing plugged in, okay? Check all these points by using a multimeter. Put a multimeter there, and you can imagine if it goes round, if there's continuity, this will be a very low resistance or fairly low resistance. If the fuse is okay, you'll go through there, signal comes there, comes to here, you push one of the buttons, and you should get continuity across the 2 mains connectors. So that's how you do it, you know, one step at a time. You go to the selenium rectifier, which is this bridge rectifier, and with a multimeter there and there, you should get continuity through the secondary of that transformer. You can actually check the diode function of this selenium rectifier. Bear in mind it is a selenium rectifier, so you don't expect to find normal diode characteristics when you test it, but you can test for shorts, shorts to ground, for example. Now, what you need to remember as well is that these transformers have pretty low resistance, DC resistance, but you will notice a difference between 0 and something, okay? Same applies to the 6 volt, 6.3 volt heater line, winding. Put it across one of the lamps, but you see the lamps will be very low resistance, so sometimes you actually literally have to take those out as well as the tubes, so you're actually measuring the resistance of that winding and not the resistance of the lamp. But you do that one step at a time. Same with this heater. This particular radio has a 12 volt heater for the ECC83, the 12AX7. Don't know why they do that. You could actually run it at 6 volts when you run the 2 heaters in parallel, but perhaps to make it quieter, it is the preamp, they decided to do it like that. So once that is done, you've got power coming in. Well, it should be coming in. You've tested the transformer separately, as I've shown in that other video. You got the signals coming out, and now you start following this line. And it is literally a question of putting the multimeter, one point of the multimeter at the positive output of the selenium rectifier. Going to the capacitor, checking for continuity in one of the points of that 3-stage capacitor. Alternatively, if you don't want to do that, then you just follow the logical step. You take it from there to there to there, and if you follow the line up here it goes into the transformer. Now, what it finds here is a very low resistance winding two ways. So it goes that way, through that winding, back here, back up, through this winding, which is also low resistance, and it goes to pin 3 of the ELL80. So if you've taken this tube out and you measure between the output of the selenium rectifier and pin 3, and if you get continuity with a small resistance, because you've got two primary windings in the way, you know that line is fine, or should be fine. The other line you can test is from here, it goes through there, comes down through here, and it goes to pin, I think that's pin 8. It's the other anode of the ELL80. Measure that, so you now have two lines that are fine. Follow any other lines that carry B+. This one doesn't, but it carries on from here to there. So if you measure from one of the pins of the resistor or from that point there that we've had before, and you measure 2, and if you don't know where this resistor is, which it's pretty easy to find, but if you don't know where it is, you find a place that you do know where it is. So you go up here, up there, and you find it goes to the screen grid of the ELL80. So pin, I think it's 9. So you measure on pin 9. Now, if you're measuring from the same point you were on before, in other words, the output of the selenium rectifier, what you'll be measuring is this line here, up there, there's a 1K resistor across here, and then all the way up here to that pin. So you should measure about 1 kilo ohm of resistance. And if you do, you know that that line is fine and that that resistor is fine. And the other point you should measure, if you carry on up here, is this point here. So you measure pin, I think it's 1, whatever it is. We'll check that. And you find that's fine, so you should measure 1 kilo ohm as well, because there's no resistance between these 2 points. So you can then color that in as being fine. But this particular line goes further. It comes across here. See, it goes up there, but it also comes across here. So it goes across here, and it goes to a switch. And this is 3, looks like H and K. I think it's K, all right? So if you look at what this means, go down here. If you go to this switch arrangement, you have switch 1, 2, 3, 4, 5, 6, and so on. And this 1 and 2 is opposite the off button. 3 is opposite the TA button, or between the two. A, B, C to K. So you find, you put your meter where you had it before, and you try and measure continuity, or rather a fixed resistance of 1K, which is what you know is there, in one of these pins. What did I say? K, so it's probably the last pin. You can also test that switch by measuring the next one up. And when you push and deactivate those buttons, one should give you a continuity and the other one should break it, which tells you that this switch is working. So now you've got to cross the switch, so you can paint it to there. Then you go to here. And this line then breaks off and it comes across up here, up here, up here, and it goes to that pin there, which I think is 6 of this EM84, which is the Magic Eye tube. So you can measure to there, and if it's giving you the same reading and you know it's connected, then you can paint that in. If we go down back to where we were, back to this point over here, and you follow it across again, and you carry on and you carry on, you carry on, and you find yourself here. If you go up here, this line goes up and it goes through a 1K resistor. So you've got to add 1K to what you expect. You're already getting 1K, remember? You add another 1K, so you should get about 2K resistance. It goes up here, across here, into the filter, through this coil, which is low resistance. You don't know exactly how much, but it's fairly low. it goes across and it's down to pin 7 of the EF80. So if you measure the expected resistance, you know you can color in this entire line. And that brings us to a point where we end up with a schematic that looks something like this. The entire start is fine. I had a problem with the switch. This was not switching on or off. It was stuck, and I had to put some lubricant on all the piano switches underneath before I got that to work. So the first thing I tried to do, I ran into a snag. It took me about half an hour to figure out how to get this thing to operate, but it's finally working. The fuse is fine. Very careful. Must make sure that it's the right rating. This is a 300 milliamp, which is fine. It said so there. Sometimes people put in 6 amp fuses there, which are worthless, and so on and so forth. Now, I've got to the point where I've got to these capacitors, and I've checked the connections to the capacitors. I haven't actually checked the capacitors. So I know they're not shorted, but I don't know whether they're leaking much. And I will leave that till after I do first power up and listen for any hum, assuming we get some sound. So that all these components in the way there, in the path, have been checked and are fine. And as you can see in some of the checks we did, some of these resistors are spot on. 1K is 1K. It's brilliant. Going up here, you see how much we've done just by checking the power connection along these lines, and all this gets painted in so I know it's done. And the same applies for parts of the preceding circuitry, and there's still some that need doing here, but this is just to give you an example of how I go along here. You take a PDF and you can actually draw on it, and you can actually make the layers you put on it semi-transparent. So this green line, I can see what's underneath, but it also tells me that that line's been checked. And this makes it easier than working on paper. I've done that before. I've actually used the schematic inside a plastic sleeve and draw on the sleeve and so on. I find this is actually the best, and I end up with less rubbish to throw away at the end. So this is what I'm going to do a bit more on. I'm going to carry on checking the power connections. There are some that I haven't done here yet, as you can see on this ECC83. I haven't checked that yet. I've checked the EBF80 and EBF89 and ECH81. So there are still a few that need doing, and that's what I'm going to do till I'm satisfied that the entire, or as much of the power line as I need to check has been checked. I'm quite confident at this stage that I don't have any major shorts. At least that's one bit of good news so far. So I think this is not something that's going to be dangerous to power up with the dimmer limiter that I use, just to avoid any drastic current flow. But before I do power it up, or when I do power it up, I will be powering up without the tubes, and then testing for voltages at the pins of the respective tubes to make sure that I've got B+ going to them. And then when I'm happy with that is when I'll be ready to put the tubes in, just the PA tubes, so just the preamp and the power amp tube. I'll take those others out and just test with a signal going into the pickup input, see if we got audio. Right, so I've got a little bit more tracking to do, tracing to do, and then I'll get back to you.